welcome to session 13. Okay, so we're talking about probability today, and you've got some notes here and you can have a look through them, but essentially with probability, everything is between 0 and 1. When you're at 0, things are impossible. Never, ever, ever. The probability they're going to happen is 0, you know? And 1 is definite. So it's at today, I'm recording this, it's a Wednesday. The probability that it's a Wednesday is 1. Okay? Now, all probabilities have to add up to 1. So you can't have a probability. I know in language we say, oh, I'm 110% sure. But actually you can't be more than 1 or 100% sure. And as a general rule, you're going to have, because we talk about what we call independent events, but and, wherever you see and in a question, you're going to think times. And whenever you think or, you're going to think plus. And there's some terms that you need to know. Mutually exclusive means they can never, ever happen at the same time. I can't be in my car and on the train on the way to work at the same time. Those are two mutually exclusive events. Okay, I can't be in my house and in another house, my sister's house, at exactly the same moment. Okay, they're two mutually exclusive events. They never ever happen at the same time. Independent events can happen at the same time, but they don't depend on each other. So I'm sat here recording these videos in my pajamas. You might be sat at home in pajamas as well. I don't know that you're in pajamas. Those are independent events, but they may happen at the same time. So they can happen at the same time, but they don't depend on each other. So that was a crap example, but you know, I could be wearing green socks and you could be wearing a blue jumper. They can happen on the same day at the same time, but they're not dependent. I don't phone you up and say, what are you wearing? And I'm going to wear this. So those two events which are independent happen at the same time, but don't depend on each other. And then everything else are just events that could happen. But that's, you know, probability, things add up to 1, 0 impossible, 1 definite. Main bit you need to know. Let's move on to some questions. So we have in a raffle, 200 tickets are sold. 200 tickets are sold. They're red or blue. Right. What is the probability that it is green? Well, there's no green ones. It's a big fat 0. So, you know, they're quite straightforward. You've just got to think logically. 79 children and 90 women buy 1 ticket each. Men buy the rest of the tickets. Okay, so how many tickets does that mean that they buy? So we're going to have a look. We're going to do 200, take away 79, take away 90. And that's going to tell us the number of men that have bought tickets. So 31. Out of how many? So probability is like, it's just a fraction. So 31 out of 200 are bought by men. That is the probability. Okay. 500 people are asked if they drink coffee. 9/10 say yes. Okay. So first let's work out what 9/10 are. So we'll have 500 times by 9/10. So we're going to divide by the bottom. So in terms of fractions, especially if you don't have a calculator, so that gives us 50, and times by the top. 9 times 5 is 45, and we add the 0. So 450 people say yes. 20% of the people who say yes drink 3 cups of tea. So out of that 450, 20%, which is the same as 20 over 100 or 2 over 10, right? Drink at least 3 cups of tea. All right, so 20% is 20 over 100 or 2 over 10. Divide by 10 gives you 45. Times by 2 give you 90. So we've got 90 people drink 3 cups of tea. The fraction is essentially the probability. So 90 over 500. We want to give it in our simplest form, and it's non-calculator, so we can cancel down the 0. 9 over 50, and that's the simplest it goes. Right, in a game, A fair spinner has 5 equal sections. Chloe spins a spinner. Write down the probability she guesses miss a turn. Well, that's 1 out of how many sections? They told us it's 5. So probability is just a fraction. It'll be 1 over 5. So then go forward 2 squares is here and here. So that's 2 over 5. So the expected amount is 2/5. Think about it logically. So if I had a coin and I said it's fair, sometimes it goes on heads, sometimes it goes on tails, it's totally fair. You throw it 100 times, you'd expect half those times, so 50 to be heads and 50 to be tails. In exactly the same way, you've got 85 and times 2/5. So you're going to divide by 5. So 85 divided by 5 times by 2, which will give you 34. That's how many you would expect. Now, the expected is what we'd say is the theoretical. It's not always true, but it gives us a good indication. Right, we've got 5 cards. One of the cards is removed. Oh, it's about a mean. Okay, so I guess this is just around statistics and numbers. The mean of the numbers on the remaining cards is 6. Okay, which card was removed? Well, let's think about that. What does the mean mean? The mean is the total over the number. So the mean is 6. We don't know what the total added up to, but we know the number of cards. 5 was 5 minus 1, so essentially 4. So 6 times 4 would give us the total. So that's 24. So the total has to add up to 24. Right, so you could do what does it add up to at the moment. So at the moment, if I do 1 plus 5 plus 7 plus 9 plus 11, it's 33. I want it to be 24, so 9 must be the card. So 9 was removed, so you'd say, well, that tells me I had 33 minus 24 equals 9, just so you can show your working. In a pie chart, one sector, so we've got a pie chart, and a quarter is coloured in. We know from all the stuff we've been doing, a quarter is 90 degrees. And the last one is about discrete data. Now, if you've read the blurb, we talk about discrete data and continuous data. So discrete data is things that are whole numbers, like number of goals scored, number of people, things you can't have. You can have halves of shoe sizes, but you can't have like 2.25555. Whereas continuous is as accurate as the measuring device. So let's have a look which one is discrete data. Okay. Height, that could be to the point whatever of a millimeter. Mass, that's going to have grams in it. Time, you can measure time to like milliseconds and even smaller. So it must be the number of televisions sold. Okay, so another short, sweet snippet. Hope that's useful. Look out for the exam papers and send me any comments or anything else you'd like. The full GCSE course will be going up in the new year, and that takes you through the higher exams, but hopefully this sort of short and sharp Resit course has been useful. We've still got a couple of sessions left, which is mainly going through more difficult and harder questions. I'm going to move away from sort of these topic-y ones and focus now, as you're coming close to the exam, on full exam papers. So there'll be a full exam paper that goes up each weekend now until your exam.